Hi everyone, in this video we are going to discuss a new unit of concentration called molarity. And so we are going to use molarity as a way to evaluate aqueous solutions. But before I get any deeper into this awesome unit, I need to review what concentration is. And I want to use words that we are more familiar with now. So talking about solute, solvent, solution. So let's start off with our definition of concentration. So concentration, in a very simple definition, is essentially the ratio of solute and solution. And so at this point in the course, we are very familiar with two different units of concentration, parts per billion and parts per million, so ppm and ppb. And we're also going to add now this big M, so molarity, okay? But we're going to get there in just a second. So before I do that, I want to review our other two pieces. So ppb, parts per billion. Anytime we're talking about ppb in this module, the way I want you thinking about it is that it is 1 microgram of solute per every 1 liter of solution. Now remember, it's solute and solution. We're not really focusing on solvent, but we do need to know about the solvent. So don't block it out completely, but it's just that we're focusing on solute and solution. All right, so that's ppb, parts per billion. So ppm, parts per million, would simply just be 1 milligram of solute per every 1 liter of solution. Okay, 1 milligram of solute for every 1 liter of solution. That's ppm and ppb. What about molarity? So molarity, not to be confused with molality. That's a completely different term. If you happen to know what that is, that's fine, but please don't focus on that. This is molarity only. Molarity is your moles of solute per liter of solution. Okay, very simple definition. And so we can actually write that out here. So molarity is usually represented with a big block M. And we say we have 1 mole of solute for every 1 liter of solution. So that's your very basic definition. And so just to reiterate, because I know some of these words are new, when you think solute, you should be thinking something that is in your solid state. I don't know why I wrote a G there. In the solid state, okay? That's what solute is. Whereas your solution is usually going to be your solute plus your solvent. So you're going to have your solid piece plus your liquid piece. It's both pieces, okay? So make sure you keep that clear in your head, what solute, solvent, and solution is, because you need to know these. All right, now the best way to practice molarity is to just do a bunch of different dimensional analysis problems. So I have 3 of them prepared for you here. So let's work through these together. The first one we have is that I'm going to tell you that a solution of NaOH, so an NaOH solution, is 5 molar. Okay, 5 molar. So that's how you say that. A solution is 5 molar. Now the question is, how many grams of NaOH were dissolved in 1 liter of water? Okay, it's a long question, but it's important. There's a lot of different components there. So a solution of NaOH is 5 molar. How many grams of NaOH was dissolved into 1 liter of water? So the first thing you have to do is identify your solute, then your solvent, then you can try to actually back calculate. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. The first thing you have to do is start off with your molar component, okay? So we're saying we have a 5 molar solution of NaOH. So what that means is I have 5 moles of my solute. That is the NaOH. That's what it's telling us. 5 moles of NaOH in 1 liter of solution, okay? Or 1 liter of water. So now how many grams are in there? So how many grams of our NaOH? That's what we're trying to solve. So right now we're in moles per liter. All we have to do is get rid of moles. So we know that we can just use our molar mass of NaOH in order to get rid of moles there. So we know from the periodic table there's about 40 grams of NaOH in every 1 mole of NaOH. So make sure you keep this clear because we have to keep our units clear here. So 40 grams for every 1 mole. So now our moles cancel out and you're left of grams per every liter of water. Solve this out, you end up with 200 grams of NaOH. Did you get it? Hopefully, yes, maybe? All right, let's try another one just in case you didn't. Next question. What is the molarity of an aqueous solution with 150 ppm of dissolved, ready for this? Mercury. Go. All right, did you get an answer? This one I think was a little bit trickier, so if you didn't, don't beat yourself up. We can work through this together. So the first thing you have to do is translate what 150 ppm of mercury actually means. So the first thing I do is get it out of the unit ppm. And so what we know is that that means we have 150 milligrams of mercury per every 1 liter of solution. And so now the goal of this is to try to get it into molarity. So molarity is moles per liter. So we're already in liters, so this bottom unit's taken care of. What we need to do is make sure we can convert out of milligrams all the way into moles. So we have a 2-step process here. So the first thing I'm going to do is get out of milligrams into grams. So I know that for every 1,000 milligrams of mercury, I have just 1 gram of mercury. Now I'm in grams. Now I can easily just use the molar mass from the periodic table of mercury. And if you look it up, we see that there's about 200 grams of mercury for every 1 mole of mercury. So now check our units. Our milligrams have canceled out, our grams have canceled out, and we're left with moles of mercury per liter of solution. So we're definitely in a unit of molarity. If you calculate this out properly, you should get something along the lines of 7.5 times 10 to the negative 4 molar, so big capital M, of mercury. Did you get it? Definitely harder, okay? So don't beat yourself up, but let's give ourselves one more shot at this to try to get this down, because this is definitely hard, but make sure you practice, okay? Just practice. That's all it will take, and you'll get it. But next question. If we have a concentration of sodium, and we're going to say it has a concentration of 27 ppm, all right, 27 ppm in terms of sodium concentration, what is that in molarity, okay? I'm trying to look for it in molarity, so convert from ppm to molarity. Go. All right, did you get an answer? Hopefully you did, because it's the exact same process as we did just before in the last question, but just in case you're not there yet, let's work through it together. So the first thing we want to do is get rid of ppm. That's not a useful unit for us. So what we want to do is say we have 27 milligrams of sodium per every 1 liter of solution. And so now we're trying to get to molarity. So our solution is good at the bottom. The only thing we need to change is our milligrams. So we can go from milligrams to grams. We know there's 1,000 milligrams of sodium in every 1 gram of sodium. And then we also know that we can use our molar mass. So sodium is about 23 grams, okay, about 23 grams for every 1 mole. And now we check our units. So our milligrams cancel out, our grams cancel out, and what we're left with is moles over liters of solution. We're definitely in the proper unit for molarity. If we do this properly, we get an answer something like 0.00117 molar of sodium, okay? Wonderful. Hopefully that makes sense. If not, that's kind of hard, but it's okay. Just keep practicing on it. Don't give up. You need to get your dimensional analysis down. Please, please, please practice. Shoot me an email. Ask your teacher if you have any questions. Good luck. Take care of yourself and drink water.